there, and welcome to more about infrared radiation. So first of all, let's talk about radiation and the Earth's temperature. So the temperature of the Earth depends on lots of factors, such as the rate that light and infrared radiation from the sun are reflected back into space or absorbed by the Earth's atmosphere or by the Earth's surface. Also, second factor is emission from the Earth's surface and from the Earth's atmosphere back into space. So if the Earth had no atmosphere, the temperature on the surface would plunge to about minus 180 degrees at night, the same as the moon's surface at night. This would happen because the surface would not be receiving any radiation from the sun. It would be emitting radiation into space. So remember, infrared radiation is the light and the radiation that we actually get from the sunlight. Some gases in the atmosphere, such as water vapor, methane, and carbon dioxide, such as greenhouse gases, absorb longer wavelength infrared radiation from the Earth and prevent it escaping into space. These gases absorb the radiation and then emit it back to the surface, which you can see here in figure 2. This process makes the Earth warmer than it would be if these gases were not in our atmosphere. So the temperature of an object increases if it absorbs more radiation than it actually emits or releases. The Earth's temperature depends on a lot of factors, including the absorption of infrared radiation from the sun and the emission of radiation from the Earth's surface and atmosphere. So this particular image, figure 2, shows you the absorption and emission of infrared radiation. Absorption means sucking up the radiation. Emission means releasing it back into space. So number 1, infrared radiation from the sun warms the ground on the Earth. Number 2, the ground becomes warm and then it emits a longer wavelength infrared radiation. And then point number 3 tells you that carbon dioxide molecules absorb and re-emit infrared radiation back to the ground. So this cycle itself keeps our Earth nice and warm, and it helps us not to go into the minus 180 degrees, similar to what we have in the moon temperature at night. Let's go into the next particular image, show you some more information. Here we go. So here, let's have a look. So more about infrared radiation. So absorption and emission of infrared radiation. So every object absorbs and emits infrared radiation, whether its temperature, no matter what its temperature is. So if an object has a constant temperature, the object emits infrared radiation at the same rate as it will absorb it. When an object absorbs radiation faster than it emits radiation, its temperature increases. So rescue teams use light-colored shiny blankets to keep accident survivors warm, because a light shiny outer surface emits a lot less radiation than a dark matte non-glossy surface. So this keeps the patient warm, as less infrared radiation is emitted than if an ordinary blanket had been used. So for example, in an accident, when the emergency services go and save somebody out in the cold, wherever they may be, they will put a very light, thin, shiny kind of blanket on a person, because this will help keep the radiation inside rather than emit the radiation. Because if it's a light colored substance, it will actually keep this heat inside. Whereas if it's a dark, matte, non-glossy surface, then it will release the heat back into the atmosphere. Okay, so have a read of this again and try and understand this as best as you can and answer the questions in the homework. We'll go into this in much more detail in our next follow-up class. Thank you so much.